Ah, 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 ah. Do you guys feel that? Oh, the earth is shaking. I gotta go duck and get some cover. Oh my gosh, I'm gonna hide under my desk. Okay, okay, I think I'm safe under here. I think I'm good. Okay, so today for science, I gotta get under more. Hang on. Okay, so today for science, I'm going to teach you all about earthquakes. Did you guys feel the earth shake? And did you see what I had to do? I had to hide under a desk. Okay, it seems like it's calm. Wait, it's still going a little bit more. Okay. Ah! Okay, I think I can come out. Oh man, I'm glad I was under this desk to protect myself. So let me come on out and get ready for today. Oh man, I was not expecting to have an earthquake, but that's the thing with earthquakes. You never know when they're going to happen. All right, guys. So as always, I'm going to put on my goggles. Might not help with an earthquake, but you know what? We're going to have them. Look, guys, I got some new ones. I look kind of crazy and I kind of look like I'm going to go like skiing or something. Do you see these? These look ridiculous on me. But anyway, I got some girly safety goggles and I am ready to talk about earthquakes. So, first thing is first, we're going to kind of discuss our reading story this week. So, our reading story is all about earthquakes too. So, in science, it kind of goes together. So, I can't wait to share with you guys some things. So, I'm safe, you're safe, we're all good. Alrighty, let's get rolling on this. So, first, we're going to talk about this guy named Alfred. So, he was a meteorologist, which is a fancy name for a weatherman. So, he kind of decided that the continents were moving. Remember in the last video, we said the crust contains our continents like North America, South America, Europe, and Asia. Okay, and Africa and Australia and Antarctica. I think I might have said some of those. But anyway, so those continents, we realized, well, this guy did. He realized in 1915, which really isn't that long ago, he realized that the earth was starting to pull apart. That crust was starting to kind of pull apart. And I talked about that in that last video. Well, he actually came up with a name for this, and this was called the continental drift, which basically means the continents are drifting apart. Now, well, here's the thing. See, that Alfred guy was onto something, but I really think that the earth has earthquakes and the continents are moving because of that guy there, that squirrel. That squirrel from Ice Age keeps trying to put that nut into the ground and he keeps cracking the earth. I blame it all on him. It is his fault. This is why we have earthquakes and this is why we have the continental drift. Nah, just kidding. I'm going to tell you the real reason why. But it is kind of cute that Ice Age connected that to earthquakes. It is kind of a good visual of how the earth kind of pulled apart. And if you want to, on your time as well, you can do that Sid Shuffle too. If you've never seen this, let's listen to it real quick. What's up, my mammals? Here we go. Ready? We're about to do this new dance, the continental drift. Here we go. Ready? It's time to get upon your feet. It's easy to do. Just follow me. Move it out. All right. And do the Sid. Take it back. And do the Sid. Anyway. Oops, I got to pause that. Anyway. Feel free. Why won't you pause? All right. There we go. So anyway, let's get back to business. I can't see with these on, so we're going to take these off. I should probably clean them off next time. So when it comes to the continental drift, we want to blame him, but we really know that there's something underneath the ground that is happening that's causing this drift to occur. And that is, they discovered that the crust is really not one hard piece and one solid piece. Underneath the crust, there are these things called tectonic plates, which are basically these things that move underneath the ground. They're not the type of plates we eat off of, but they are just pieces of land underneath the ground that move in certain ways, okay? Or apparently they ninja fight. No, they just move. Okay, so we are going to talk about the three type of plate movements that we have under the ground. So remember, we have the crust, and underneath the crust, we have these plate movements. Earthquake again. Oh, man. I'm glad I'm prepared and right next to this desk. All right, so there's three types of plate movements that we're going to discuss. And as always, Mrs. Adamson always has food with her to demonstrate science. You know what? These might blow up. So I'm going to put my goggles back on because, again, I think something might blow up today. All right. So this cookie is going to represent our earth. Okay. It's going to represent our crust. And the brown part of my cookie is going to represent the crust pieces themselves. And then the white is going to represent the mantle and the melted rock that we have inside the earth. Okay. So I'm going to use this cookie to help demonstrate some of our plate movements. First, we have something called convergent plate movements. Say that with me. Convergent. All right, so basically that means two plates under the ground that move together. So watch. So these two plates are going to move together, and I want you to realize what's happening to my icing. So as these plates move together, the land starts to push up, and that melted rock, which is my icing, starts to push through. So these type of plate movements, convergent plate movements, they actually will create new land. Oftentimes volcanoes are created from convergent plate movement. Mountains are created because you see, I'm going to do it again with my cookie. Now my cookie's falling apart. But when I do this with my cookie and I push it together and you see these plates are moving towards each other, they're pushing the land up. And that land is my icing right there. The earth tastes delicious. All right, so that is convergent. Now, when we do convergent, I like to do movements to help us remember. So when I say convergent, I want you to take your hands and I want you to have them hit each other and push up. That represents that the plates are hitting each other and then they are making the land go up. So do that with me. Convergent goes up. Excellent job, guys. I'm sure you're really rocking this out. I can't really see you, so sometimes I feel like I'm talking to myself, but I know you're rocking it. So again, push your hands together for convergent and push them up. All right, the second type is divergent. It kind of sounds like die. So say that with me. Divergent place movements. So these are when the plates actually move away from each other. So I have another cookie here. This is when I take my plates and I pull them apart. Do you see how it's making a big gap in the middle there? It's pulling, it's pulling, it's pulling. So what's going to happen is the land is going to split apart. You're going to have little chunks of land left in the middle. Okay, maybe you have water that drains in here. So this is how sometimes rivers and lakes and streams are formed. This is how canyons are formed because the land pulls apart and the stuff goes down. Okay, the land goes down. Now, what's kind of cool about this one is in Iceland, I cannot see. I got to take these off, guys. It's really blurring. So in Iceland, so this is actually happening to the land. If you look at this picture up here, their land is actually pulling apart from each other because they have plates underneath that are constantly pulling. And I want you to keep in mind, our earth is not only spinning through space and revolving and rotating, but it's also constantly moving underneath our feet. This crust is. So there is a perfect example of Iceland coming apart. And who knows within the next 100 years what that will look like and how far that gap is going to get in between those two pieces of land. Now, for convergent, we came together and we pushed our hands together and went up. For divergent, we're going to take our hands and we're going to pull them apart. If we were in class, we would do this with a partner and pull ourselves apart. Okay, so convergent, they come together. Divergent, they come apart. All right, and the last one. So this one I just like saying because I really like Transformers. This one is what we will most likely experience here where we live. And this is what causes our major earthquakes, okay? So this is called transform plate movement. And this is when the plates move past one another, okay? So they kind of go like this. Look, and look how messy my hands get with the transform because they're sliding. And just like the land on the crust would break, my cookie is breaking apart because of the friction and the tension. And look, this is when, we actually have things that come apart because these plates are moving back and forth and they are breaking the earth. This is what you'd often see in movies where you'd see like a crack going across, okay? So, to practice transform, take your hand and I want you to slide them back and forth past each other. Now, as you're doing this, your hands should hit each other. And that hitting is what we would feel if there was an earthquake, okay? Now, this happens on something called fault lines. Remember how I said it was the squirrel's fault this was happening? Ha, get it? It's fault because these are fault lines and they run underneath our crust. They run underneath the United States. We actually have several fault lines here in the United States. So for transform again, we're going to take our hands and we're going to pull them back and forth and let them bump into each other. Okay. One fault line is called the San Andreas fault line, and that's in California. I'm going to show you a map of that. All right, so here's a little bit more about faults, okay? And remember, it's a squirrel's fault this is happening, but really it's just lines and rock movement underneath the ground, okay? So faults occur at plate boundaries. So those plates that are underneath, these fault lines are just cracks in the earth, and it happens where this movement occurs, okay? All plate boundaries are faults, but not all faults occur at plate boundaries. So basically, if there is a plate boundary and a fault, an earthquake could likely happen, okay? And one of those three movements could happen. It could bump together, it could pull apart, or they could slide. All right, guys. So I want to show you a map of the United States. In fourth grade, you guys learn about, my hands are so gross. Look at this. I have a bunch of earth on my hand. All right. So, in fourth grade, you guys learn the states, and we start in the Northeast, which is over here, and then we go towards the West. So eventually you'll know where these are. So this right here is Illinois, where we live. This is where a lot of our fault lines are at. So we could at one time have an earthquake because we have those fault lines underneath us. So those plates will transform and hit each other. When will that happen? Nobody knows. Okay, there's really not any true way to measure when an earthquake can happen. They have ideas, but there's not like, oh, it's going to happen on Saturday. Or you know how we get tornado warnings and we kind of have an idea of when those would happen? Earthquakes are a little bit harder to kind of measure and to figure out when they're going to happen. Okay, we just know at some point it could. Now, sometimes the earth gives us a little bit of signs, and I'll show you how that is. Okay, so we live on a fault line called the New Madrid Fault Line, and then there's another one in California called the San Andreas Fault Line. Now, in between here, there's a bunch of other fault lines, but these are the two major ones in the United States. So, if you're wondering, could we have an earthquake here? Absolutely. There are scientists and geologists that study this all the time to ensure that we are semi prepared. But again, it's hard to predict when 100% these will happen. Okay. They can kind of do some measuring of it, and I'll show you that. All right, so an earthquake, what is an actual earthquake? So it's a violent shaking of the Earth's crust by the plates. Remember, we talked about those pulling and pushing and sliding when they are pressing against each other with enough pressure until one of them breaks free and kind of jerks, okay? So when those get really angry, think of it as like a stomach ache. The Earth is kind of having a stomach ache that's happening, and then all of a sudden it breaks apart, okay? So, we are going to read about the epicenter, and that's the point on the surface of the earth directly above the focus. This is where the intensity of the earthquake is the strongest. So, earthquakes, let's say it happens here in Belleville. So, let's say it happens right here, but because earthquakes can be so strong, it can be felt all over the place. The main part where that earthquake happens is called that epicenter. So if it occurred right in the crust below Belleville, let's say below my house, that would be the epicenter and the focus. So that's where it's the strongest, okay? But it can occur along that whole fault line. So if you look here, this whole fault line is right underneath us, but it just happened. Let's say this is Mrs. Adamson's house. It just happened right under Mrs. Adamson's house. That's where the worst of it was, okay? So earthquakes can be strong in some areas, but then they could be felt even states away. Sometimes when they happen in Illinois, other states feel our earthquakes just because of the power and the severity and just the intensity of the plate movements. I just find the earth so fascinating, guys. All right, so this is how they actually measure. I'm going to float my head somewhere else. Let me move myself. So, this is how we actually measure the earthquakes. So, there is something called a seismograph that studies it. And to me, it kind of looks like a little kid just kind of squiggling. But what this is doing, it is measuring the earth and how the earth is feeling at the time. Okay. And if you've ever been in a hospital and somebody's been hooked up to a machine before, oftentimes it reads your heartbeat measurements just like this too. And it shows you the movement that's inside your body using electromagnetics and everything, which we're not going to get into all that. But science is just so fascinating. Okay. So they use this to measure how strong the earthquake is, and it kind of also gives them an idea of when this earthquake might actually happen. Again, there's no like beep, 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 earthquake happening in 15 minutes. Okay. It's not like a tornado warning or a tornado drill or even like looking at the sky when a storm is coming in. It's really hard to identify when an earthquake is going to happen. But I'm going to read off to the side. By using seismographs, scientists can measure the energy of an earthquake called the magnitude. So basically, our Earth is constantly giving us energy. There's energy, energy, energy. Well, when the energy increases, just like you get kind of cray cray sometimes. Maybe you eat that sugar, or maybe you eat a cookie and you get a sugar rush. Okay, think of it as an earthquake being the Earth's sugar rush. It's going a little crazy, getting a little out there. So this seismograph picks it up and is able to tell the scientists and meteorologists, hey, there is an earthquake that might actually happen. But then we will see, not only does it detect earthquakes, but if an earthquake happens, guess what? Guess what? Lean in closer. Guess what? Guess what? Guess what? Sometimes a volcano can erupt. Ah! Stay tuned for the next one. Ah! All right, I'm going to show this video so you guys can see a little bit on how a seismograph works without actually having one in front of you. I'll put my goggles on.
How a seismograph works. A seismograph is an instrument used to measure the movement of earthquakes. A weight is suspended in a way that allows it to remain still when the ground moves. Most modern instruments use an electromagnetic mechanism for this. A writing instrument is attached to the weight, allowing it to record the movement as it happens. The word graph refers to the writing action. Most modern earthquake monitoring uses seismometers, not seismographs, and record the movement of the earth digitally, or output the data to a seismogram, a printed version of the wavelengths on a large drum. These wavelengths that represent Earth's movements are so small that in order for scientists to study them, they have to be amplified.
So again, it uses the energy to measure it. So I hope you learned a whole lot about earthquakes, and maybe you're a little bit more prepared for an earthquake if it were to happen. So I want you to think, what would you do if all of a sudden, you felt that? Would you go under a desk at home? What would you do at home if you felt an earthquake happening? Because, it's nothing we can 100% prepare for, but we can have a plan in place if we do happen to feel the earth shake sometime.